Hello viewers, in this question we are asked to convert the hexadecimal number A.14 into octal. Okay, so let us start with the conversion process. So the hexadecimal number which is given to us is A.14 with a base of 16. So this must be written as A.14 because if we read it as 14, then it will give us another kind of meaning because 14 in hexadecimal number system, as we know, we can represent A with 10, B with 11, C with 12, D with 13, and E with 14. So if we say that A.14, it will represent A.E, which is not the true case. So what do we need to do? We will read it as A.14. Okay. So this hexadecimal number has two parts. The part which is present on the left hand side of the decimal point, the part which is present on the right hand side of the decimal point. The part which is present on the left hand side of the decimal point is known as integer part. This is the integer part, and the part which is present on the right hand side of the decimal point is the fractional part. Okay, this is the fractional part. So we will find, at first we will find the binary equivalent of the integer part and binary equivalent of the fractional part, and after combining them together we will get the binary equivalent of this hexadecimal number. And once we get the binary equivalent of this hexadecimal number, we can easily convert the binary number into octal number. Okay, so let's start with the process. So here the integer part is same. So in order to convert the hexadecimal number into binary number, we will write the hexadecimal number as a group of 4 bits. Okay, so we will have to write A, which is equivalent to 10, as a group of 4 bits, right? So if we write 10 as a group of 4 bits, it will be like this: 1010, because the positional weights are 8, 4, 2, 1. So 8 into 1 plus 2 into 1, which will be equivalent to 10. So the integer part is giving us 1010 as binary equivalent. And now for the fractional part, we will represent 1 and 4 with 4 bits. We will represent 1 with 4 bits and we will represent 4 with 4 bits. So we will represent 1 as 0001. So as I have said earlier, the weights are 8421. So as the bit 1 is present for the positional weight of 1, it will give us a equivalent of 1. And for 4, we will write 0100. Similarly, the weights are 8421. So if we write the bit 1 for the positional weight 4 only, it will give us a equivalent of 4. So for the integer part we are getting 1010, and for the fractional part we are getting 0001, 0100. So if we just combine them together, we will get our decimal binary equivalent. Okay, this is the binary equivalent of the hexadecimal number, that means this number. Now we need to convert this binary number into octal number. So in order to convert the binary number into octal number, what do we need to do? We just need to make a group of 3 bits. Okay, but if there are not 3 bits in the binary number, like in this case there are total of 4 bits. Okay, so if we make a group of 3 bits, like if we take 101, then 0 will be left out, so we cannot represent 0 with a octal number. So this is a unlikely scenario. So in order to make a whole group of 3 bits, like if we make, there are total 4 bits in this number, if we make this number somehow 6 bits, so we can easily make two group of 3 bits. Okay, so in order to make two group of 3 bits, we just need to add 2 bits, and we have to add 2 bits in such a manner that the value of this number doesn't change. So for this reason, in the integer part, we will add 2 zeros at the front. So this is our binary number. After adding 2 zeros at the front, the value will remain the same. So now we can easily make group of 3 bits. We will make a group of 3 bits for this 001, and after that we will make group of 3 bits for this 010. Okay, so for 001 we will be getting 1, and for 010 we will be getting 2. Okay, because the positional weights are 4 to 1, and similarly the positional weights are 4 to 1. So if we just say this is 1 and this is 1, so we will get 1 and we will get 2. And now for the fractional part, we will just do the same, but we will do the same scenario again: 0 0 0 1 0 1 0 0. Now we need to see if there are a group of 3 bit possible from this binary number. So these are 4, 4 plus 4, 8. So if we make group of 3 bits, so 3, 3 plus 3 is 6, and 2 bits will be left out again. Okay, so we need to add 1 bit. Okay, if we add 1 bit, then the total number of bits will be 9. So after that, we can easily make a group of 3 bits, and the total number of groups will be 3, as there are 9 bits in the number. But in the fractional part, in the integer part, we have added the 0 at the front. Okay, but in the fractional part, we won't add the 0 at the front, we will add the 0 at the back. Okay, this one thing we need to remember. In the fractional part, we are adding the 0 at the front, but in the in the integer part, we are adding the 0 at the front, but in the fractional part, we will be adding the 0 at the back. So 0 will be added here. So now the total number of bits are 4, 4 plus 5 will be 9. So we will take a group of 3 bits. So the first group will be 0, 0, 0. The next group will be 1, 0, 1. And again the next group will be 0, 0, 0. So 0, 0, 0, this will have a equivalent of 0. And this have a equivalent of 5, because 4 to 1. So 4 plus 1, 5. And this will have a equivalent of 0. So if we just combine them together, which will give us 1, 2 for the integer part and 0, 5, 0 for the fractional part. And we can discard this 0 because it has no value at all. So we can write 12.05, and this is our octal number. So we will specify the radix of 8. Okay, so this thing we need to note, that in order to make a group of 3 bits, if we can't make a total group of 3 bits, if some bits are left out, we need to add zeros. But in the integer part, we will add zeros at the front, but in the fractional part, we will add zeros at the back, and then we can easily make group of 3 bits and write the equivalent octal number. So this will be our required answer. Thank you.